Hey guys, all right, we're going to be working with section 2.5, 97 to 99, so it's going to require a lot of review skills of graphing for you guys. So these are called piecewise functions. So if we piecewise functions, so if we were going to take this idea of a piecewise function, it's pieces of multiple different graphs. So there's a couple of things that we got to deal with. Number one, we have to deal with the fact that there is this new thing out here that is like a set of rules. Okay. So this is your set of rules, and it has to do with your domain. So if you notice, they all have X's here. There's an X there, there's an X there, there's an X there. So let's just tackle these first. So if we're going to say that this right here is the y-axis, and this is the y-axis, y-axis, and this is the x-axis, then I'm going to go over to -4. So I'm going to start here. Here's 0 and 0, so here's the main intersection. 1, 2, 3, 4. So right here at this line right there, we're just going to do this really light dotted line right here. Okay. So we've got this really light dotted line. I'm also going to go over to 0. I'm going to make another one. So my other one is right here at 0. So wherever x equals 0, I have this little dotted or dashed line. Okay, and then I'm going to go over to 3. 1, 2, 3, and I'm going to do the same thing. So I've got these spots on the graph where I've got these dotted lines. These are the spots that these lines can't cross. Okay, so if we're going to take something like y equals -3x, so we're going to start with that one first. Let me change the color. Let's go orange here. So if we're going to say y equals -3x plus 0, when x is less than or equal to -4. So y equals -3x plus 0. So basically what we're saying is this. My y-intercept is equal to 0, and my slope is equal to -3/1. So we start at the y-intercept. We go to the y-intercept, and I've got a slope of down 3 and over 1. So down 3 and over 1, and that means it's over 1 and up 3, and then over 1 and up 3. 1, 2, 3. So we've got this thing that's way up here. Of course, it doesn't work on this graph, so it's way up here. So we keep going. All right, so we have this big, long. So if we draw this, we've got this graph. I cannot draw straight lines. This is not going to work. All right, so you've got the idea of that it goes up in this general direction, but the key piece is that we only want it where y equals 0. Where x is less than 4. So we only draw our line right here. So we're going to draw our line we're going to take our extension and we're going to draw our line here like that, because it tells us that we want everything less than 4 when this line is good. I know the graph doesn't fit very well, but it's kind of the way it works. Okay, so that's kind of where we start. Now, if we look at this one here, we're going to do this one in a different color. This one's a little easier to see. We'll do this one in purple. So it's y. This is the second one. This is the second one right here. Y equals x. I'm just going to add a 0 because there's nothing there. When, or if, they use the word if, 0 less than x is less than or equal to 3. So if I look at this, I can plug these 2 points in. So I could say y is equal to 0 plus 0. So y is equal to 0. So my first point is 0 and 0. So I'll go to 0 and 0 right here. And then, in fact, what I'll do is, since this is an open circle, I'll write an open circle here. And then if I take 3 and plug it in, so y is equal to 3 plus 0, 0. That means y is equal to 3. So my point is, when I plug in 3, I get 3. So I go over to 3, 1, 2, 3, and I go up 3, 1, 2, 3. And since it's a less than or equal to, and then I draw my line between the two. So I'm going to draw my line between the two. I'll start it here, and I'll go to right there. So I've got my line there. Okay, now my next one is y equals 8. So let's look at this here. Where's my, there it is. So y equals 8 when x is greater than 3. Y equals 8. So if I plug in 3, I get 8 because y equals 8. If I plug in 4, if I plug in x equals 4, y equals 8 because y equals 8 always. So after this point, we're going to go up to 8. 1, 2, 3, 4, 5, 6, 7, 8. We're going to put a solid dot, and y always equals 8. Y always equals 8. So then we just take our line, and we draw it straight out this way. It's not a very straight line, but so we've got our y equals negative 3x here when x is less than negative 4. We've got our y equals x between 0 and 3, and we've got our y equals 8 here when x is greater than 3. So we're just drawing chunks of lines, and we're stopping whenever it tells us to stop for the domain or the rules or different things like that. Okay? So when we look at this, and it's really hard because of the graph. Let me, it's not going to let me shrink it, is it? Let's see here. Yeah, there we go. It's a little smaller now. So when we look at these things, the graph has a domain, In other words, where are all the x's? Well, the x's are from negative infinity. So our domain is x is less than or equal to -4. It's between 0 and 3. And it is greater than 3. Oh, that should be an open circle. I just realized that. It's an open circle because that one is greater than. This is a greater than. All right. So that's our domain. That's pretty much your domain right here. This is how it follows the domain. And now our range is all the y values. So my y value goes from here to here. So my y value is from 0 to 3. Oops. It's open circle, so it's less than 0 to 3. So that's my first y value. That's my range this way. Y is always equal to 8. And then if we look at this here, if we go right here, I need to know what that point is. Well, that point's at -4. So if I plug this in, I get y is equal to -3 times -4. Y is equal to 12. So let's go, and it's got to be above that. So y is going to be greater than or equal to 12. All right, guys. So that's how you graph each piece. It's going to rely on some old graphing skills, guys. So I am sure some of you may struggle with this a little bit. Just ask questions because you're going to have to remember how to graph on these. I can see that the intervals will be confusing. We'll practice some more of these, but that'll get you started. All right, so let's look at this piecewise function here. I'm going to make this a little bit larger. Oops. So there's 3 different graphs here, guys. So they want you to write the function. So we're going to use this 3 times. Y minus y1 equals m times x minus x1. All right, so we can, let's just take this first line right here. Take that first line right there. And I'm going to pick these 2 points. I'm going to pick this point right here. And that's -8 and 4. So y equals, oops, not equals, Control Z. So my point that I pick is 4 and -8. And then if I just count the slope, 1, 2, see, this is 4, and this is -4. So if I go from here to here, it's 2, 4. Each line's 2, and then 2, 4. So my slope is -1. All right, so if my slope's -1, then I can write my equation as a line right here. So I get y minus a -8 equals -1 times x minus 4. So it's y plus 8 equals -1 times x minus 4. This, you can't really see it, but this is at -3 right here. So it's anything to the left of -3. So when x is less than -3. Okay. All right. So let's take that other one here. You got to watch the scale on these two, guys. So I'm going to change the color on this one. So that was the first one. That was the left one. I'm going to go to yellow here. So we're going to go with this point here and this point here. So let's take our 2 points. This one is going to be over -3 and down 2. So our first point is -3 and -2. And then our second point is going to be, it looks like, I kind of made that yellow dot too big, so it looks like 1 and 2. Okay, so our slope is going to be the change in y, which is going to be left minus right. And then our change in x's, which is going to be left, -3 is an x value, minus 1, which is an x value. So that's -4 over -4, so that's 1. So we pick a point here. I'm just going to pick these two because they're positive. I'm going to pick this one here, and we're going to get y plus 2 equals 1 for my slope times x minus, oops, this is minus here, x minus 1. And from where? From -3, which is right here. This line only goes from -3 to 1. That's our domain for that line. When x is -3, and they're solid circles, so to 1. Now, we've got this one here. We'll do this one in red. And we have y is always -6, so it goes on forever. So that means y is always equal to -6. Where? From x is greater than or equal to 4. Because look, it starts right here at 4. It's an open circle. Gosh darn it, I keep doing that backwards. It's an open circle. X is greater than 4. All right, guys. So we're either writing equations or undoing equations. All right, so here's our last one, guys. So y equals a times bx minus h. Oops. Minus h plus k. Okay, so this is our vertical shift. H over b is our horizontal shift or phase shift. And then A is just the steepness of the graph. Kind of replaces amplitude. So it's kind of like our trigonometry functions. So absolute value functions are always shaped in a V. So we always have a V shape like that. They're always a perfect V. That way the distance to the left and the distance to the right are the same. So when you graph these, this here is what's going to shift left and right. So let's look at this here. So we know that we have f of x, and then we've got, so let's look at the steepness is 2. My horizontal shift is the opposite of what you see in there. So my horizontal shift, or my phase shift, if you want to call it that, is 4. And my vertical shift is 6, because that one's K. So if we look at this, this one's K, this one's H, this one's A. B's 1, so it doesn't really matter. All right, so now let's look at this piece here. So let's just take it to a graph. And if I go to a graph here, and sorry for my vertical lines that are horrible, and I go over 4 because I'm shifting 4. I'm going to go 1, 2, 3, 4, 5, 6. And then I wanted to go to 4, and then we're going to go 1, 2, 3, 4, 5, 6. We go over to 4, we go up to 6. So I went over 4, up 6. That's what it told me. And then all I do is draw my V. So I draw my V here. Oops. You can follow the steepness if you want to. You can go, this is like an over 2 and up 2 and over 1. It's kind of like a slope. So you can go over 1 and up 2 like that. And then you can go over 1 and up 2 as long as you do it the same on both sides. And then if we take that and we put our graph right there, we're going to draw one like that. I missed it just a little bit. And then we're going to draw one like this. I'm going to do that one again. So our graph looks like that. It's just a V at 4 and 6. So don't forget, that is your new vertex, which is 4 and 6. All right, guys? A little longer video. Hope to see you soon. Good luck.